Now we need to talk about similar triangles. Before we talked about similar polygons, and of course triangles are three-sided polygons, so we're going to just focus in on those for a minute. Let's suppose, well, when we talk about polygons, a triangle being a special case, remember what we said. We said the corresponding angles are congruent. So here we have two triangles, ABC is congruent to DEF. Notice the corresponding angles are congruent, and the corresponding sides all have the same ratio. So notice that here we've got AB right here is proportional to DE, and so forth. And you could go around all the sides. Notice you have BC, this angle right here, is proportional, or the same ratio. It corresponds over there to EF. So this is, when this happens, we have similar triangles. Now, just let's think about this. If these triangles were congruent, they would still be similar, right? So all the angles would certainly be, every angle would be congruent to its corresponding angles, and all the sides are congruent to their corresponding sides, so the proportion is still there. The proportion would be 1, right? AB divided by DE would be 1 because it's the same length. So just to clarify that, congruent triangles are also similar. Now, we're going to focus in on three right away for this section. We're going to focus in on 3 ways that we can identify similar triangles. The first is called angle. If 2 angles in one triangle are congruent to 2 angles in another triangle, then the 2 triangles are similar, period. All you have to do is find in one triangle 2 angles and find those same 2 angles in the other triangle, and you can say those 2 triangles are similar by angle. Now, I've got an example of that here. Notice we've got the 90-degree angle and the 35. And because we have 2 angles from each, right? 90, of course, is congruent to 90, and 35. So we could say that those 2 triangles are similar to each other. So that's pretty straightforward. That's an easy thing to do if we can just identify 2 angles. Now we also have side similarity theorem. Now, don't get this confused with side for congruence, because in side for congruence, we said if each side was congruent to its corresponding sides, then the angles were congruent. We're not saying that the sides are congruent. We're saying, notice what it says here. If the lengths of the corresponding sides of the 2 triangles are proportional, then the triangles are similar. So in other words, I've got a picture here. Notice this side AB over PQ. That's the same as BC over QR, which is the same as CA over RA. That is the side for similarity. And you can see that over here. Let's look at this. Let's see if that's the case on this one. Now, first of all, 4 is going to correspond to the 2.4. So let's just see what we got there when we do this. We've got 4 over 2.4. Now, that's a fraction, and one with a decimal in it. One of the things you can do is multiply the top and the bottom by 10. In other words, move the decimal over one place on the top and the bottoms, just the same as if you multiplied the top and the bottom by 10. And then you get, for some reason, this is easier for us to work with. But now look what you get here. We've got, let's see here, 4 will go into 40 10 times. I'm just reducing the fraction now. 4 will go into 24 6 times. 2 will go into 10 5. So it looks like that ratio is 5/3. So now let's look at the other ratios. So here we go. We've got 7 over 4.2. Okay, let's see how that goes. That's 70 over 42. Now I play the same game here. I'm reducing this. I've got 35 over 21. And then this is going to be 5 over 3 because 7 will go into 35 5 times and 7 will go into 21 3 times. So 5/3. So yeah, these ratios are the same. So these two triangles are congruent by side, side, side. Now there's another one. There's the side angle side. Okay. So now let's see what this is. Now remember, there's a side angle side for congruence as well. But here we have two angles are congruent. Okay. If an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the side, including these angles, are proportional, not congruent, but proportional. Okay. So let's see if that's the case here. We've got 3 over 2 for this one over this. And then we've got 5.4. Okay, let me move this off to the side here. Whoops. Maybe that's too big of a task for me. Now, so that was 3 over 2. Now let's do this. We got 5.4 over 3.6. I'm going to move that decimal over, 54 over 36. And now let's see here. 18 will go into 36 2 times. And 18 will go into 54 3 times. Oh, yeah. So the ratios are the same, 3 halves and 3 halves. So this is an example of side angle side. Okay, so there you go. Now we can play around with this one a little bit, and look here. We've got 3 sets of triangles. 3 red blue pairs here, and we can see. I wonder if they have if these are proportional. Well, you could do this. You could say, okay, 4.8 divided by 3. Does that equal 1.6 divided by 3? Divided by 1, I'm sorry. Just using the corresponding parts. And does that equal 4 divided by 2.5? Okay, and we could go through there and work through it, But yeah, the fact is they're all equal to 1.6. So this is side, side, side. Now let's look over here. Here we've got a 60-degree angle. Good, a 60-degree angle. Oh, this is a 45 and this is a 75. But wait a minute. If I do this, if I say 180 minus 60 minus 45, what do I get? Do I get a 75-degree angle there, I believe. So that means we do have, in this triangle and this triangle, we have 2 angles. So this is going to be angle, angle. Yeah, that's what that is. Now let's look over here. Oh, this is side angle side here. Because notice that this and this are congruent. This and this are congruent. So those sides, this side divided by this side is the same as this side divided by this side. So we have side angle side. Yeah, that's it.